Hello and welcome, my dear grade 10 elite students, to the end of term coverage, the last and final part 3 for your coming term 1 exams. I hope you are watching all my videos which I'm making for you, especially to get good marks for your exam. And I hope before watching this part, you have watched part 1 and part 2. I will put in the link in the description box. Please watch them so that you understand this video better. And a gentle reminder to all of you to like, share and subscribe to my channel. If you're watching my videos and liking them and benefiting them, give it a thumbs up, leave a good comment how it is benefiting you, and also share this video with most of your grade 10 elite friends who are giving the exam, so they may also benefit from the same. So let's get started and see what questions we are covering today. So we start with module 4 today, and we are covering from lesson 4.1 operations on function. This is very easy question. You have to find the sum, the difference, the product and the division for each of fx and gx from question 1 to 6. Let's solve them one by one. If you see, the first function fx is given, the second function gx is given. So the sum is just got by adding them. Connect the like terms, combine the like terms. That is the rule that you have to use on addition and subtraction. So when you add 2x minus 4x becomes minus 2x plus 5. And when you subtract, the sign changes for minus 4x plus 5. So it becomes plus 4x minus 5. So it gives you answer 6x minus 5. When you multiply, you use distributive property. So 2x multiplied with minus 4x plus 5 on distribution would give you minus 8x square plus 10x. So this is the answer. And when you divide, you just have to keep it in the same way. There is no common factor that can be cancelled. The only thing is that denominator, you have to remember, when it is division, cannot be 0. That means minus 4x plus 5 cannot be 0. That means x cannot be 5 by 4. So this is an important point that you have to take care when you are writing division. Similarly, for question 2, you can find fx plus gf, fx minus gx, fx multiplied with gx and fx divided by gx. The only thing you have to be careful that when you are dividing, the value of x cannot have denominator 0, so x cannot be 2 by 5 in this case. In a similar way, you will solve question number 3. Next we solve question 4 and question 5. So for question 4, when you are adding, there is no common term. So you are going to just add x square plus x minus 5 and leave your answer as it is. When you are subtracting also, there is no common term. So you will leave your answer as x square minus x plus 5. Now why there is no common term? Because this is square function. The power is 2, and this is or square function or quadratic function, and this is linear function, so they don't have anything common. So when you are multiplying, just use the distributive property, multiply, use law of exponents and get your answer. So how I'm multiplying, in case any student has forgotten, this is same as x to the power 2 multiplied with x to the power 1. So power gets added, 2 plus 1 minus 5x square. So this is x cube minus 5x square. That's how you get this. Now when you divide, you have to make sure that the denominator is not equal to 0. So you put the value of fx, x square, you put the value of gx, x minus 5, and you say that x cannot be equal to 5 because the denominator cannot be 0. In a similar way, you will solve fx plus gx, fx minus gx. Here you have common term because both of them are square or quadratic functions. So you will combine the like terms very carefully. Minus x square and 2x square would give you x square. So this is the answer. And when you subtract, remember the sign of the term which is getting subtracted changes. So it becomes minus 2x square minus 3x plus 5. And when you combine the like term, you get minus 3x square minus 3x plus 11. Similarly, you multiply, use distributive, and it is going to give you this answer. When you divide, the denominator cannot be 0. So for 2x square plus 3x minus 5, I'm writing here 2x square plus 3x minus 5. You have to do the factorization. So what are the two numbers that are going to help you here? 2x square plus 2x minus 5x minus 5. Take 2x common, so x plus 1 minus 5x plus 1. So 2x minus 2 and x plus 1. This cannot be 0. That means x cannot be equal to minus 1 and x cannot be equal to 5 by 2. So this is how you get your answer for this question. Now we move on to lesson 4.2, inverse relations and functions. So here you need to find the inverse of each function. The equation is given to you from question 5 to question 14. Then you have to graph the function and graph its inverse. If necessary, you have to restrict the domain of the inverse so that it becomes a function. Okay, so a lot of things to be done. Long questions and long answers will be there. There will be 4 steps that we will follow to find the inverse, and then for the graph we are going to graph the function and the inverse using y equal to x line. Okay, so let's see for these questions 5 to 14 what are the 4 steps that you will be following. I will write down the steps and then we'll see step by step solution. Okay, so to find the inverse, step 1 would be to replace fx, or sometimes in the question it is given gx or hx, whatever is given you replace it with y. Okay, then in step 2 you interchange x and y. That means if it is x written in the function you put y, where there is y written you put x. Step 3, solve for y, and last step, step 4, replace y with f inverse x or g inverse x or h inverse x, whichever is given. Okay, and I want you to remember here that f to the power minus 1 x, this is how you write inverse of fx. Okay, so learn these 4 steps, 1 2 3 4. These are very very important. In each of the question we are going to be using these steps. Take a screenshot so that you remember them, learn them, and let's see how we apply them. So for the first question, fx equal to x plus 2, I told you step 1 is replace fx with y. So rewrite the function as an equation of y. This is step 1, where you write y equal to x plus 2. Step 2, interchange or exchange x and y. So in place of y you write x, in place of x you write y. You get this equation. Now solve for y. So when you have to solve for y, you put the 2 on the other side. So y is x minus 2. And last step, third step is done. So fourth step, last step, replace y with f inverse x. So what is the inverse function? X minus 2. Now comes the graph. So first we will do the graph of x plus 2. So x plus 2 is this graph, straight line. Now I told you when we are going to do the graph for the inverse, we are going to use the line y equal to x. So this line which passes through origin, the broken line, the dotted line is y equal to x. Remember, the inverse is always symmetric about this line. So if this is x plus 2, then this is x minus 2, the inverse, and as you can see it is symmetric about the line. In a similar way you can do the next question. So what do we do here? We write gx as y, then we exchange x and y, then we calculate y and replace y with g inverse x. So this is the inverse. Again, if you draw the graph, this is y equal to, this is y equal to fx, this is equal to y equal to 1 by 5x, and both are symmetric about the line y equal to x. In a similar way, you will solve question 7 and question 8. I'm providing here the detailed solution of question 9 to question 12. They are to be solved using the same steps that we have seen, the 4 steps, and the graphs are going to be symmetric about the um, line y equal to x. Now, I want to discuss one more question here, which is question 13 and 14 are similar. So here I'm going to discuss this because the graph is a parabola, it's not a straight line. So here when you see the graph of f inverse x fails the horizontal line test, that means it doesn't become a function. So you have to find the restricted domain of fx so that f inverse x will be a function. So look for the portion of the graph that is 1 1. If the domain of fx is restricted to minus infinity to 0, minus infinity to 0, this point, then the inverse is negative, and if the domain is restricted from 0 to infinity, the inverse is positive. So here you see f inverse is getting two values, plus minus. So you restrict the domain, you say that f inverse of x, I am writing how you will restrict, is equal to minus of 5x over 5 if x lies between minus infinity to 0, close bracket, and it is plus 5x over 5 if x lies between 0 to infinity. So this is how you restrict the domain. Similar restriction is done here so that the graph is symmetric about y equal to x. You can see if the graph is here, this is symmetric. If the graph is here, it is symmetric about the line y equal to x. Next we have question on graphing radical functions. The function is given by the equation f of x is equal to a times square root of h x minus h plus k. Okay, so because it is a radical function, we have taken the radical symbol x minus h. H is the horizontal translation, k is the vertical translation, and a is giving you the dilation, the factor of dilation. Okay, so let's write the radical function for 37 and 38 in the next slide. Okay, so first of all, you identify the index because the domain is all real numbers greater than or equal to minus 4, and the range is all real numbers less than or equal to minus 2. The index is even. The function can be represented as f of x equal to a times x minus h plus k. This is the equation. So identify the transformation. The function has been translated 4 units left. So what is the horizontal translation? H is equal to minus 4 and k units down. So k is minus 2. Because it is left, it is negative sign. Because it is down, it is negative sign. So h and k you have identified, put them in the equation. To find the value of a, we use a point as well as a value of h and k. So just substitute, simplify, and to get your a, we are using a point 0 comma minus 4. Just look here, this point, is it lying on the graph? Yes. What is the coordinate of this point? The coordinates of this point is 0 comma minus 4. So put that in the equation, get your value of a, substitute the value of a, h and k to write the equation. So the graph will get this equation. Similarly, for this question, the equation of the graph would be this. So solve similarly and get your answer. Okay, let's now do operations with radical expression, lesson 4.5. Here we need to divide and simplify rational expressions by rationalizing the denominator. So if you see carefully, question 29 and 30 have square roots. So it has the radical sign, no number is mentioned. So if no number is mentioned, it is square root written in this way, in exponential this way. Okay, so you are going to rationalize the denominator in all 4 of these expressions. That means we are going to multiply the numerator and denominator by the same number by rationalizing the denominator. Now, how we are going to do that, we'll see in the next slide. And here the powers become very important, like a to the power 5, b to the power 13 is there in the first question. So b to the power 13, we are going to simplify it by opening. So let's see how we solve question 29 and 30 in the next screen. So for writing the rationalization, we are going to factor into squares. How do we do that? A to the power 5 is given, b to the power 13 is given. How can I write this as powers of 2, powers of square? Why squares? Because it is the radical sign or the square root outside. So I'm going to write a to the power 5 as a to the power 4 multiplied with a, which is a square to the power 2a. Okay, why we are doing that? So that we can take this out of the radical sign in the next step. So a square comes out, inside you are left with square root of 5a. Okay, similarly in the denominator, b to the power 13 can be written as b to the power 12 multiplied with b, or b to the power 6 to the power 2 times b. So you write it in this way and you take the b to the power 6 outside. So a square and b to the power 6 comes out. Inside you have only this expression. Now you are going to rationalize the denominator because you don't want the radical sign or the square root symbol in the denominator. So the square root of b can be removed by multiplying with square root of b in numerator and denominator. When you do that, the numerator becomes square root of 5ab divided by denominator becomes b dot b, so b square. Now this will be going out of the radical symbol, just giving you the symbol of absolute value of b, and now the radical is removed from the denominator, means we have rationalized the denominator. So on simplification, the final answer is going to be this. In a similar way, you are going to factor into squares for question 30. Here you see x square, so x square is going to come out of the radical, it will give you an x, and you are going to then rationalize the denominator by multiplying with square root of 10x, numerator and denominator. So numerator becomes 70x square, which is x times square root of 70. Denominator becomes 100x square, which is 10 times x. So the absolute value of x comes into place, and this is the simplified form. So this is the method of evaluating the radical expression by rationalizing the denominator. Now we need to solve question 31. So this one is an important question and I want you to pay attention to both of these questions. Now here you are given cube root. If you see this is given, that means this is same as cube root. And in this one, fourth root is given. That means it is the same as 1 by 4. So that means when you are doing the rationalization of the denominator, you have to make sure that how can you remove this cube? How can you get rid of this cube root? That's why you know that you have to multiply with 5 square y square. Why 5 square y square? Because when you do with 5 square y square, it will become 5 cube y cube, which will go out of the cube root in the last step, and therefore the denominator will get rid of the radical sign. So the rationalizing factor would be this. Also 3 and 3 will khalas, so you will just multiply both numerator and denominator with the same term, which is cube root of 5 square y square. So when you do that, 25 multiplied with 6 will be 150. X square will be as it is. Y square will be added to it in the numerator and cube root. Denominator would be 5 multiplied with 5 square. So 5 cube and y cube. Now cube root of 5 cube y cube is same as 5 cube y cube to the power 1 by 3. So this will give you 5y. So 5y will come in the denominator, and this is the simplified form. Now look at this question where there is fourth power. So fourth power means you want to get rid of the radical sign in the denominator. So 4 is already there, so you need 4 cube. B square is already there, you need b square. So this is the rationalizing term in the question. Multiply, simplify, and this comes out to be this solution. Let's solve the radical equations from lesson 5-6. Here, if you see carefully, in all the 6 questions that are given on your screen, the radical is 3. So here, the power which is there is 3 outside the radical. Here 1 by 3, that means it is same as square root of 3 or cube root. So here also you see the power is 1 by 3 in an exponential form. Here the power is 1 by 3, here the power is 1 by 3, and here the radicand has the index as 3. So when the index is 3, it is same as cube root. So let me just remind you in case you have forgotten this value. If the radicand outside is 3 means it is cube root, and it can be written in exponential form as this. So this is the radical form. This is the exponential form, but both are same. Okay, and this is same as cube root. Okay, cube root of a. So same way, all of these three questions we will be able to solve if we are able to remove the radical. And when we remove the radical, we have to remove this 3 or 1 by 3. So how do you do that? By taking cube of both sides of equation. And when you are taking cube of both sides of equation, there are some extra roots that might come in the solution. So you have to, before you give the final answer, check your solution by using substitution. So let's go to the next slide, solve the questions, and there I will explain you what are the important steps. Look at the first question. This is this one. So here I told you we have to take cube because we want to get rid of the radical. So when we take cube of both sides, I do cube here, I do cube here. Cube of 3 is 27, and here this cube root and cube will cancel to give you this. Now we have got rid of the cube root. So just solve for r, and r is coming out to be this. Now you have to check for extra roots. So how do you check? You substitute r equal to 11 in the original equation, this one which is given. So you put r as 11. So 3 times 11 is 33 minus 6, which is 27, and the cube root of 27 is 3. So both sides are equal. If both sides are equal, the answer is correct. So answer is 11. Next is this exponential equation. So both of them will be solved in the same way because both are exponential equations. Both have power 1 by 3. So take cube of each side, remove the exponent, and the value of d and t will be this. Now before you give them the final answer, you have to check by substitution. So when you check, this is true, so this is correct answer. When you check, this is also true, so correct answer. So there are no extra or no extraneous roots in these three questions. Correct. Again, for these three questions also, we have to take cube of both sides. And before we do that, in this question, we are going to move the 4 on the other side. Okay, because you cannot take cube like just like that. So you move the 4 on the other side, it becomes minus 4. And now you remove the negative sign, so make negative negative positive, and then you take the cube. So when you take cube, the power, the exponent removes, and you just get 1 minus 7u, and 4 cube is 64. Solve for u is minus 9. Now you check your answer by putting this value of u in the equation, solve it, and both sides are equal, so that means your answer is correct. In a similar way, solve this question. V comes out to be this one. Check your answer. It is correct. Again, for this question, you have to just do a little steps before you take the cube. That is, move 1 on the other side and move 4 also on the other side. So when you move 1 on the other side, it becomes plus 1. When you move 4 on the other side, it gets divided by 4. Now you take the cube. So what is the cube of 1 by 4? 1 by 64. Now you solve for n, and n comes out to be this fraction. Now put the value of n in the given equation, simplify, solve, and you will see that both sides are equal, so your answer is correct. Again, in this case also, there are no extraneous roots. Let's now solve questions on lesson 5.1, graphing exponential functions. So when you are graphing, you are given the equation like this. Now observe, then for all the 4 equations, the base is less than 1. The base is less than 1. What is the base here? 0.25. What is the base here? 1 by 2. What is the base here? 0.8. What is the base here? 2 by 3. So it will be decreasing function. These are graphs of exponential decay. Why it is exponential decay or exponentially decreasing? Because the base to which the power x is raised is less than 1. So that's one thing you know before even drawing the graph. You need to find here the domain, which is the input, the range, which is the output, The y-intercept which you get when x is put 0. The asymptote is the line which almost the graph looks like it is touching, but it is not touching. So it's like a tangent to the graph. And then end behavior. End behavior means the behavior of the graph towards the endpoint. So what we are going to do, we are going to draw an x and y table. So you all know how to draw the table of values and then do the graph by joining the dots. So that is what we are going to do for these 4 questions. And then we are going to answer about the domain, range, y-intercept, asymptote, and end behavior. So let's do it on the next slide. So here in this slide, you see the 4 graphs. All of you can see that they are decreasing, they are decreasing, they are decreasing, and they are decreasing. So we've already seen that. So now we do the table of values. So for different values of x, how we are going to choose the values? Some negative points, 1, 0, and then some positive points. Okay. So when x is 0, how much is fx? 1. That means the y-intercept is going to be 0, 1. Also, when you join these dots, the graph comes like this, decreasing. So you can see that the graph looks like it is touching the x-axis. So here the asymptote would be the x-axis whose equation is y equal to 0. So asymptote would be that. Now let's talk about domain and range. Domain, I told you, is input which comes from x-axis. So what are the x values that it can take? It can take positive, negative, 0, all the values. So all real numbers would be the domain. And this is going to be the same answer for all the 4 graphs. Just check. Domain is all real numbers, y-intercept is same. Domain is all real numbers, y-intercept is same. Even the asymptote is going to be the same, because all 4 graphs, if you see, they look like they're touching the x-axis but not touching. So x-axis or equation y equal to 0 becomes the asymptote or the tangent to the graph. Now let's talk about range. Range is coming from y-axis. Y-axis means you will look at the y value. Now all 4 graphs, if you can see, are on the above side, positive y-axis. There is nothing below the x-axis. There's nothing on the negative y side. So therefore the graph cannot take negative y values, and the range would be all positive real numbers for all the 4 graphs. So range is coming from y-axis, so all positive real numbers. Now comes the end behavior. Again, the end behavior for all the 4 graphs would be same. So the only thing that you see is changing is the base and the table. So the table of values is changing, which you can get from the calculator very easily. So fx equal to 1 by 2 to the power x. Here fx is equal to 2 by 3 to the power x. So only the numbers are changing as you see here, but everything else is same. So the end behavior, let's explain the end behavior. I will explain it on this graph and I will change the color. So as x is decreasing, as x is going to minus infinity, where is this graph going? Up. So as x decreases, y increases, and here as x increases, y is going near about 0. It's touching the, almost touching the axis. Okay, so your end behavior would be, as x goes to minus infinity, means on the negative side, means it is decreasing. It is going to this side, negative. It is going to f of x, the graph is going to plus infinity, going up. And as x is going towards plus infinity, fx is going, or y is going towards 0. So the same end behavior is going to be there for all the 4 graphs. Let's solve lesson 5.2 question, solving exponential equations and inequalities. So here you are given 6 exponential equations. Why exponential equation? Because the variable or the unknown is in the power or the exponent. So very easy to solve these equations. Let's solve them in the next screen, and before we start solving them, I will give you the hint that will help you to solve the question. So for question number 1, the base is same, 25. So you can just compare the powers and use the power property of equality. Okay, so this property is what? That the base is same, then the powers are equal. Here it is 9 and 81, so you make the base equal. So how can you write 81 as a base of 9? 9 square. Similarly, how can you write 4 as a base of 16? 4 square is 16. So on. So just make the base equal in each of them and then you solve using power property of equality. Okay, so here since the base is same 25 and 25, just equate the powers using power property of equality. So 2x plus 3 is equal to 5x minus 9. Move 2x on the other side, solve for x. So the x comes out to be 4. Okay, similarly in this one you write 81 as 9 square and then use the multiplication rule of power. So to multiply 2 with 3 gives you 6x, 2 with 6 gives you 12x. Now 8x minus 4 is equal to this one. Solve for x and x comes out to be 8. Next is 4 to the power x minus 5 is equal to 16 to the power 2x minus 3. So write 16 as 4 square and multiply the powers. So multiplying the powers gives 4x minus 62. So the bases are equal, 4 and 4. So the power has to be equal. Simplify and get your value of x. Here the base is 4, here the base is 8. So you make both the bases equal. So how do you do that? You write 8 as 2 cube and you write 8 as 2 cube and then you simplify. So this becomes 4 to the power 12x minus 2. Okay, there's a mistake in this step. So we are going to correct that. Let's do it here. So 4 can be written as 2 square. So 2 square multiplied with 3x minus 3 and 8 can be written as 2 cube. So 2 cube 4x minus 4. Now because the bases are 2, both are equal, so the powers are going to be equal. So 6x minus 6 is going to be equal to 12x minus 12. Now comes this step. So instead of this 4 which is given wrong here, it will be 2. Now you solve for x and your x comes out to be 1. Similarly, you solve this question, question 5. So in question 5, one base is 9, one base is 27. We convert both into 3. So 9 can be written as 3 square and 27 can be written as 3 cube. Multiply the powers, you get these values. So equate the powers and get your x. Similarly for this one, write everything as a base of 5 because 125 can be written as 5 cube and 25 can be written as 5 square. So use that value, simplify your equation and get your value of x. In this lesson from 5.4 geometric sequences and series, we have to determine whether each sequence is geometric or not. So you are given from question 1 to 6 some numbers and some pattern and some sequences. You have to check whether they are geometric or not. So let me recall about a geometric sequence. So when is a sequence said to be geometric? It is said to be geometric if the ratio of any term to its previous term is constant. This is called common ratio. So if you divide, if you take any term like 7 and it divided by 5, if you take any term 13 divided by 11, if you take any term 9 divided by 7 and the ratio comes out to be same r, which is equal for all, then it is called a geometric sequence. So let's use this concept for solving questions. So let's see the first question. In the first question, we have terms 5, 7, 9, 11 and 13. So you take any term like 7, divide with the previous term 5, you get 7 over 5. Similarly, 9 over 7, 11 over 9 and 13 over 11. Now all of them are different. They are not the same. So the ratios are not the same. So there is no common difference. Therefore, the sequence is not geometric. Next we have 3, 6, 12, 24, 48. If you start dividing the term with the previous term, like 6 divided by 3 it is 2, 12 divided by 6 it is 2, 24 divided by 12, it is 2. 48 divided by 24, it is 2. So all are same. So the common ratio is there, therefore the sequence is geometric. Again, here in this sequence, 2 minus 4, 8 minus 16, 32, it is the same common ratio, which is minus 2. So it is also a geometric sequence. Next one, 400, 200, 100, 50 and 100. Here also you divide the term 200 divided by 400, 100 divided by 200, 50 divided by 100 and 25 divided by 50. So all the ratios are same, equal to 1 by 2. So since the ratio are same, the sequence is geometric. In a similar way, you can find the common ratio for question 5. All of them are different since they are not same. The sequence is not geometric. And for the next one, the ratio is same, so it is a geometric sequence. That brings us to the end of today's session. A humble request, a kind reminder to like, share and subscribe to the channel. Share this video with your grade 10 students or grade 10 elite students who are giving the exam, with your friends who will benefit from the video. Until then, this is Ms. Ruchika signing off from today's session, wishing you all the very best for your coming exams. Bye-bye.